Okay, Phil Mitchell here. um, Making this video to visually show, I guess, my knowledge and my capabilities with Excel, building cost models, estimating in general. With 20 years experience, I've worked for many various types of companies doing very different things, one from another. So I picked up on a lot of different means and methods for estimating, doing your forecasting. When I was managing, forecasting your labor requirements, your equipment, and material, and all that, and doing your budgeting and all that. So when I'm in interviews or if I'm talking with people about my knowledge in Excel, I tell them I have advanced knowledge, and some people have some knowledge and they don't know what advanced knowledge is. So this is a way for me to show you instead of trying to explain. So this was developed for my current company. There were steel, structural steel and miscellaneous metals, were fabrication and erection. So they fab, structural and miscellaneous metals. Miscellaneous metals being stairs, railings, bollards, ladders, like the small stuff. um, so, and the primary purpose of this is an estimating, software estimating program, where you're, quantifying, all the different items and requirements for the job. One of the things about structural steel, which is different than a lot of other trades, is that it is extremely dynamic. It's not just picking out a certain size or just getting a square foot of something or per each. Every item is varying in the purpose, what's required to fabricate a certain member. It's always different. So and then also you have your overall fabrication requirements for the shop. So trying to pull all that together into one program. That was the purpose of this, and to speed up our estimating our takeoff uh, process. So quickly, uh, everybody's familiar with doing quantity takeoffs. So structural steel, we're picking the main member size. I won't go through all of them, obviously, just to show you there's multiple ways to do the same thing. I prefer this method where you can choose the exact item you're looking for. Most software is where you have a drop down menu, but then you have to sort through lots of items that you don't need to find the one that you do. I mean, W sections are very easy, channels are easy. When you get into the angle and tube steel, it gets to be a little bit more cumbersome. Where there's a lot more factors because of the same size tube but different wall thickness. So let's go down here. I gotta find the one I want here. It's an 8 by 4 by half length. Or again, I prefer this method, where you can just put in exactly what you're looking for. That by half, that by four. And then, oops. And then if the requirement changes, it's got to be an 8 by 6. You can just change the 8 by 6. Versus the drop down, you have to sort through again, you guys find you got to sort through all the ones that you don't need. Very minor thing, but it's just a personal preference, and we're doing this every day, all day long. Those couple of keystrokes add up. Um, that's that's just picking out a a generic stock, uh, you know, uh, member size. One of the things about steel is plates. There's many various types, sizes, and purposes for plates. And so when I was first developing this program, it was a little tricky to figure out how to incorporate the structural steel, along with other the accessories and with the plates, because they're different than say it's tube steel. It's just basically you're picking this item and a length and a quantity. Whereas plates, you have thickness, the size of the plate, and then also what type of the purpose of the plate. So we select my plate option. Here you have the different thicknesses, right? That's fairly common, but anyway. And then the purpose of the plate, what it's for. So when you're doing takeoff and you're going back through and reviewing the estimate, you're making sure you're picking up the proper plate size, the proper plate requirements, I guess. Plates again. Let's pick a gusset plate. Usually it's 6x6. All of those. Now, stiffeners are very different. There's many different types of stiffeners and purposes, but for this example, I'll just go off of generic stiffener for a beam. So typically, you would kind of guess that W12 stiffener will probably be 3, we'll say by 12, right? 12 of those, or uh, so, again to speed up less keystrokes when you're doing it every day all day long, you can choose the exact beam or size beam that attaches, so it's the proper size and weight and all that. That's one thing I've done. Uh, One thing about plates are now the way the labor works, which I'll go into a little bit later, is this when especially comes to plates. The hours um, includes burning it, fabricating, cutting the plate in the shop, but also fit up and welding it in the shop. But there are times when things have to be welded in the field. So in order to be able to do that efficiently and keep everything in a more cohesive, I guess, linear fashion or standard way of taking things off, and to identify what's being shipped loose or what's being welded in the shop, I just ship loose option, which did not work. That worked, and that worked. Why did this work? I gotta look into that. But it did work. Okay. Yeah. Okay. So there's your. So it takes out the hours from typical welding in the shop. Now we're looking at just straight cutting it, burning it, cleaning it, and then sending it out. Um, some of the other, I'm not going to go through everything, but obviously, decking. We all know you're just picking out the kind of decking it is and the quantity. No magic there. We're a bolt shop, so anyway, but we have a lot of connections that choose, and this is going to grow. Sometimes you need slotted, you know, connection angles instead of just bolted ones. Again, the accessories, bolts, expansion bolts, anchor bolts, all the generic stuff. And this would be a little bit more, you know, comprehensive if the company I work for had been developing some kind of database over the years, but they really are way behind the times, and I'm trying to bring them up to 2019 standards. Um, so we're getting there slowly. Again, grading isn't same thing. All you do is picking out items out of database that are some known purchase quantity with plus some kind of labor to those things. Um, one of the things especially these days is there's tons of breakdowns, analyzing your bid, analyzing your pay schedules and all that. So well familiar with the scope items. So this is a way to just scope item one. Everything that you would enter below here would be underneath scope item one. And takeoff. And then the S is for structural. Scope item two. Scope item three. And then because we are also a miscellaneous shop, we do miscellaneous items. There's an M item that everything under here would be an M1, M2, M2. Let's put M3, and everything underneath these scope items would then summarize into our scope breakdown. So everything that we take off, shop hours and all that stuff, and the materials. If there's a field erection, it all gets summarized under here, and I'll show that later. Don't want to dwell too much on the blank page. I just wanted to give you just a quick, um, you know, visual explanation of me creating a takeoff and estimating program, and that there's different ways of capturing items, quantifying things, than just selecting a drop down menu. But also figuring out how to make this work in Excel is also a challenge. So if I go to a job that's been already taken off, and go through here. So this is on some job that we estimated. I forget how big it is, but if I just quick go to the scope breakdown, you can see there was 20 24 different different scope items. And again, here's how I'll summarize it so you can see which scope item has the most beef in it, where's all the work, um, and you're able to check your check numbers, right? Your prices per pound out the door. Check your fabrication times. If your shop or if your company does do proper job cost tracking, if they're you know either doing time studies or constantly tracking your shop fabrication times. This is just again just summarizing things to give you a good handle on we've captured all the costs. It's either it's within the range or it's out of the range. And so this is $10 a pound. This is definitely out of the range, but there's a purpose. There's a reason why it is. And so anyway, it's just it's a way of checking yourself. Um, One of the things, again, with databases, we're pulling these items out from this database, and the way the database works is you're pulling not just the item, not just the weight and the say a generic price per pound. You're also the fabrication times are varying, and what happens is, especially with steel, um, the length and the weight, the size of a member could drastically reduce or increase, your productivity. So a heavier member is going to be thicker, a 12 by 65 versus a 10 by 54. It's going to be close, or 8 by 31. So it'll be larger in size, but thicker in steel. So it takes longer to cut, takes longer to drill. There's also how many holes. Like again, to be dynamic because of every part is different. If something has to have additional holes drilled into it, if you have miter cuts that are required, if the ends have to be coped, all that time has to be captured somehow. I know a lot of shops just do a per pound equation. They just some unit pricing, but that does not. In the overall, it's going to be close, but it does not really capture what is required. And there's no way of backtracking and doing your proper forecasting and checking that the estimate's right or the shop is right or what is wrong. And that's what this program attempts to do is to account for all that. So if we take these items here and say if both ends are getting coped, then adjust the labor accordingly. If there's 10, 12 holes required for each one of these, then it will add the time in that's required. Um, One of the things, I don't think I have. No, not yet. Let's go breakdown. So this thing is decent size. Oh, it says 500 tons, so it's got some beef to it. Um, Again, another way to analyze the job, see where we are with our fabrication time. Um, Create this cut list. What this does is it takes your neat takeoff, all the requirements, and it lays it out in nominal 1 foot increments. So uh, a W14 by 445. If there's one part that's 1 foot 2 inches, on here it's going to say it's a 2 foot piece, and it's just a way for an estimating way to quantify something and add a little bit of fat into it. So if we do the cut list, um, again this might take some time depending how big the job is. So here we go. So this is going to show you. So there's 32 C 8 by 13.75s that are 2 foot and under, 164 5 foot, the C 4 by 5.4 under 5 foot. This job is 80% of the items are under 10 feet, which should speed up your productivity. But anyway, I usually print these out on 11 by 17, and it's just a good way to visualize everything in a quick snapshot. Um, when you're looking at, again, your labor, how many hours per ton are we at? What's the price per pound that we're fabricating? Does the estimate say we're at? And if you have historical data, again, it's a way to check and analyze, your bid, your estimate. Now, with another dynamic thing with steel is, unlike most scopes or you know, I guess scopes of work, there's we have to buy stock order lengths, and then depending on the requirements, we may have to order significantly more quantity, uh, based on the actual cut lengths that we need. So we have to figure out what our waste factor is going to be, right? So here's a neat takeoff, and then to get a more accurate way to figure out how much waste is this job going to be at, I have our stock order. So we're going to start the stock order list. And what this does is it just, in a linear fashion, just takes that cut list matrix and puts it in a vertical fashion. I copy and I paste that into my nesting software here, and then I can export that to Excel. That put in our final, basically our final. Now again, this is estimated. It's not 100% exactly because it is only an estimate. So I built a little bit of fat into it. So we go back to our cut list, and now we're at 4.5% waste. So we can add the waste factor on there appropriately. And it's a good way to check. This is what we've estimated that much weight, that much waste. So when we're actually buying the job out, we find out if we're correct, if we could go back in here and change some of the cost modeling or some formula here and there, or as a way to challenge the project managers that they're ordering the proper materials. Now we'll go to the fabrication summary. We're going to check our fabrication times. So again, what this does is it pulls from the estimate, obviously, summarizes, how many W sections, how many WTs, Ls, and all that stuff, where all the hours are. And you can see it's 4,000 hours of fit and welding. So there must be a lot of plate, tons and tons of plate here, and additional shop hours. We had 627 additional shop hours on top of just the normal, um, just a regular strip welding of plates. And again, this is a quick summary for the shop that they can, in a snapshot, they can see what's coming down the pike. And when they see there's 4,000 hours of fitment welding, I mean that's that there's a so they can identify overtime, so subbing things out to other smaller shops. Um, what kind of finish is on here? Sometimes if there's a lot of uh, heavier, more labor intensive finishes, then the finish hours will be way up. So anyway, and then also too, so here's our fab hours per ton. Is this in line with the type of job it is, with our historical data? You know, again, just constantly doing your check numbers. And then below is it's again, this is just summarizing. There's 18 WT 3 by 7.5s in total, and there's a total meat takeoff quantity anyway, and then the hours associated with each one of those, and then the fabrication per pound in a generic, probably 50 cents a pound or something. I don't know what it is. Plus here it is 55 plus our shop rate, and then so it's just a way to identify that the estimate is in line, it's incorrect with our historical data, and to it just summarizes the materials in one easy fashion here. So plates, yeah, see there's a lot of plates. So most of the hours are here in the plates. That's why there's 4,000 hours. Okay. I'm not going to go into the erection really, um, but you know this S1, we got 70 picks. I don't know. We just generically put 45 picks a day, crew size. We can change the size of the crane that's required if we have to. So we only had 110 ton crane for 2 days, and then that obviously will affect the scope breakdown, which you should be familiar with. I didn't want to go too much detail with the labor. It gets a little boring and cumbersome. But I've created something that adjusts with the size. It adjusts with the requirements. If it's shorter or longer, if you have 5 foot pieces, it's the the time is much faster because you're taking, say, a 20 or 30 foot piece, and you're cutting them up in 5 foot pieces. You're able to bundle them up in the shop and move them around faster as long as you can manhandle them. Now, if you have, say, 25 footers, now it's way different. Now, each individual piece has to be picked from the yard, has to be gone through the shop. It's much longer. It goes through all the equipment slower. Obviously, cleaning and painting, takes longer. So that adjusts with that. And then, like I explained with the weights, the heavier something is, the longer it takes to drill and to cut, and it moves around the shop slower. So I've accounted for that, and there's also a way that we can backtrack this if we're doing proper time studies and proper job costing. If we're in tune with the shop, then these hours should be more, a lot more accurate. And um, I guess I should show you a little bit. One of the other things again with having a structural and miscellaneous shop, uh, we have again with the concept of having a drop down where you're sorting through all these different items. When you go to miscellaneous metals, it complicates things drastically because there's so many things, so many variables. So if we go with railings, here you have these are the different types of railings, right? Baluster rail, 10 line, 9 line, 3 line, whatever it is. Then there's a diameter of that's it's almost always inch and a half, but there's 2 inch, and there's other square tube and stuff like that, but was an inch and a half. And then you have to incorporate the finish: prime steel, galvanized aluminum, anodized stainless steel. Is it powder coated? Let's see, prime steel. So now if I had all this as a drop down, it would take forever. Stairs, same thing. There's your it's just a way to move through a matrix basically faster. Prime steel, and these are not the proper prices. I just put $200 in as a unit price, and then it divides out the hours. Some of that, but bollers, ladders, right? What kind of ladders are there? You should be familiar with assemblies. So we have some stair assemblies, right? Basically, the stringers, a platform, guardrail, handrail, how many field labor days, and then equipment. So it just helps speed things up a little faster. What else we got bracing, right? Almost always there's some small angle, some gusset plates and bolts, and some field time. And this is the one I've been trying to hone in on a little bit more. Are these turnbuckles? They seem to be showing up a lot more often. Same concept, just a way of quantifying things a little faster. Um, welding, regular shop welding. What kind of weld is it? What kind of weld is required? And is it a standard, like horizontal versus a vertical and overhead? There's a different labor requirement. So it's 12 foot long, and there's four of them. And it's continuous with it 8 hours. So let's say if it's one, so it should drop down. Drop down drastically. Mostly everything else is just selecting items in a database. I mean, there's no real magic to that. The magic really was, to me, is figuring out the labor requirements and how to capture that properly, how to track it properly, and then how to be able to go back into the database and adjust things accordingly. So let's go to plates. So with the plates, you know, is our plate production, on target? If we're tracking things properly, then we should know exactly, uh, how long a plate should take. I have other spreadsheets that backs up, the plate productivity, the welding times. Um, a lot of these times, come from myself doing my own time studies. I work for a smaller steel fabricator that was doing my own time studies every day, almost everything I was doing. Um, and then there's written literature, there's web forums, there's other other guys I've met who've worked for other shops, um, and kind of what their knowledge was, and that's kind of where this has come to at this point. Um, Again, I'm not going to go through every one of these options, what all these do, but it was just mainly to show, my knowledge in Excel, and also, building cost models, building databases. Um, I've done them for concrete companies, for general contractors, general trades contractors, for high end millwork guys. Um, some mechanical, like heavy mechanical companies. This one is just so right now I'm at a steel fabricator, and this is what I've done for them. When I started there, they were still doing typing each item in manually. So they would type in HSS 6x6x3/8. They would look up the weight per pound and put it in, and then they would sit there and kind of like manually just kind of like guesstimate like the hours per each item. So I've developed this for them So we're able to take off things significantly faster at a much more accurate way of quantifying hours, material, requirements, um, and so we can track ourselves better. So that is that's what I got for you. I hope you saw something that intrigued you. Um, so clear it.